In this session, we are going to build job scheduler based on priority of. Previous session, we had learned about building job scheduler based on the first and first order principle. Here, we make use of ranking based on priority of the job. You see here, there are three jobs that are lined up in the queue based on linked list with priorities around each job. Priority is based on linked list implementation, and lower the priority value, higher is the priority for scheduling. Meaning, if priority is 0, it's scheduled first. And if priority is 11, which is greater than 0, it is scheduled after priority 0 job is done. So we need to insert jobs based on the priority values by locating the corresponding index into the linked list. And when the job is ready for scheduling, it's pulled out from the head or front of the run queue. We will now try run three new jobs that we plan to schedule into the existing run queue. So the two new jobs will be with ID 36, which is a Vim editor, and priority would be 14. And then we have another job. This is followed by Vim, which is at ID 2, and priority is 1. The name is Step. I'm going to pull up this over here and then schedule it one after the other. So now if I'm required to schedule Vim, I'll have to bring it up here and then position it accordingly into the run queue based on the priority. Now I'm going to make use of current pointer and traverse that until I hit position where current net pointer has a priority which is lesser than new job's priority. So let me draw that right away. I'm going to have current pointing to head initially, and now when current is pointing to head, priority of the first job at head is 0, which is lesser than priority of the current job that needs to be inserted. So I just traverse to the next position. At next position, we have priority 11 for the current pointer, and priority 11 is still lesser than 14. So I need to traverse to the next pointer. However, current next is having a priority value 21, which is greater than the job priority, and therefore I halt current priority there as is and attempt the insertion of the new job at that position. For insertion, I'm simply going to change the pointers accordingly and manipulate them right away. So currents next is going to be the new job, and new jobs next is going to be the currents previous next. That's it. Now we have inserted job. Next we have one more job that's flowing away for scheduling. So that is ID 2 and type with priority 1. So I just bring it here. We need to reset the current pointer back to head and then traverse that until current next priority is lesser than new job's priority. And then we insert it at that position as current's next. So now we see if the priority of the current node that is pointing here is lesser or greater than that of the priority for the new job. 0 is lesser than priority 1. However, current's next priority is greater than new job's priority. So which is 11 is greater than 1. So we need to insert the new job between current and current's next. We change the position of the pointers accordingly. That's going to be current's next is going to be new job, and new job's next is going to be current's previous next. So that's going to be this. So priority for scheduling it goes like this, and therefore we have job with ID 11 having priority 0 to be scheduled first, and then we have ID 2 with priority 1 to be scheduled next, followed by ID 44 with priority 11, and then ID 36 with priority 14, and then finally we have ID 21 with priority 21 that needs to be executed finally. With this background, we'll go ahead and implement it. Goal of this session is to build a job scheduler based on priority of job. The run queue where the jobs will be placed for scheduling will be implemented based on priority queue with linked list. We'll now start coding. We'll begin with package main. We're going to import FMT package for logging and printing some messages. We have the function driver, which is the scheduler. So I'm just going to say invoking scheduler. So we are done with the basic template. We'll now build the scaffolding with job scheduling function and the schedule operation. Before that, we need to identify the job structure. So we will define the job structure. As we had learned in the overview session, we know a job comprises of job ID, its name, and then it also holds the priority this time. I'm going to say type job struct ID of type integer. Next we have name that's going to be of type string, and then priority of each job we can keep that also as integer. And because this is going to be a run queue based on linked list, we will have a pointer to the next node of type job. Priority is going to be integer, and then we have the next node of type job. So this is going to be a basic run queue with type linked list. This is basically a linked list node that is defined. Now we'll have the priority queue defined. So I'm going to define priority queue. Priority queue is going to hold this job, and we are going to have the handle for the linked list type priority queue. And that's going to be a structure. It's going to hold the head node to the linked list or the run queue that we find. So I can keep this as smaller case and yes. So this is the basic definition of the node or the structure that's going to hold the job that is coming in. We'll now have to instantiate the priority queue. That is done usually during constructor initialization. So we will have priority queue instantiated here. Create a priority queue or instantiated. We're just going to say create or instantiate. This is going to be a constructor. So I'm going to say function constructor, and that's going to return priority queue. So just going to take this, can be a pointer to priority queue. return priority queue. We'll initialize the variables for the priority queue, which is head to be nil initially. It is going to be. Now here we can have jobs inserted. So we'll do that later. It needs to be curly brace. Yes. Okay. So now we have two tasks left over. That is insertion of the job into the run queue and then removal of the job from the run queue, which is equivalent to DQ operation or scheduling. That's the primary job. We'll do that right away. So we are set to build the run queue and insert the job that is coming in into the run queue based on the priority. So let us define the function here. Insert a job into the run queue based on the priority. Function insert job that's going to take name, string, and priority that's going to be integer. We also take the ID value that's going to be integer. So this is a smaller case string. Okay. Now we are going to create a new node of type job. So we're going to say job and then define all of that here. ID is ID that's coming in here through the insert job function. Next, name is again coming as an input parameter. And then priority is prior. That's coming as an input parameter. Fine. Now we have defined the values and next is going to be initially nil. So we have defined the structure here, the job structure. Good to go now. And insert the job into the run queue based on the priority value. So lower the priority value, higher is the priority. Further, we insert the new job into the run queue. We check if the queue is empty or if the new job has higher priority. And if it has higher priority, then the head node, we make the new job as the head node. So let's do that now. If the queue is empty or if the new job has higher priority, meaning the priority value of the new job is lesser than the priority value of the job that is sitting on the head of the run queue. If a run queue is existing, we insert the new job at the head node. So here, if the new job has higher priority, make it a new head. So we'll see here if head equal to nil. So where is this head coming from? This head needs to come through an interface here. So we call this as this of priority queue. So we can call this as the dot head. So if run queue is empty, or if new jobs priority, that is job dot priority is lesser than this dot head dot priority, we make the new job as the head. Job dot next equal to this dot head, and this dot head is job. And once we are done with insertion, we have to simply run. This can be equal to also or lesser than as well. The new job's priority can be lesser than or equal to the priority value. Otherwise, we need to find the position where the job can be inserted based on the priority. So find the position to insert the new job based on the priority. For that, we need to keep track of jobs that are available on the run queue. We need to walk or traverse over the run queue and identify the right position. So I'm just going to make use of a new pointer that I'm going to call it as cur or current pointer that's going to point to head node initially, and use this as a walker or make use of traversal over the linked list. I keep traversing cur until priority value of current next node is lesser than or equal to priority value of the new job that is coming in. So for cur dot next not equal to nil and cur dot next dot priority is lesser than or equal to new job priority, I keep walking. In the moment it becomes greater, we'll need to insert the new job between current job and current next job. Cur equal to cur dot next. This is uppercase. That's what we have defined in our structure here. All right. So when we are done with this loop, basically when we are done with traversing, I'm going to write it here as walk or traverse until the position for insertion is hit. When we are done with this loop, we are at a place where we are good to insert our new job or new node between current first next node. So insert the new job now between current cur dot next. So I just need to modify the pointers of cur and cur dot next. So for that, I will make jobs next node as cur dot next and cur's next node as job. That's going to be done here. So I'll say job dot next equal to cur dot next and cur dot next equal to job. That's it. Now we are done with insertion. So we look up. So we are done with addition of new job to the run queue. With further, we are required to implement the scheduler or the DQ operation which performs ejection or removal of the job from head or front of the queue and schedules it. Basically, this function inserts the job based on the priority and lower the value of the priority earlier the job is put in the queue for scheduling. We go with implementing the scheduler, we can verify insertion of the job into the run queue by creating the priority queue object in the driver. Let's do that right away. We're going to create the priority queue object or essentially instantiate the priority queue. So I'm going to say PQ object is, I'll invoke the constructor here. Our constructor has so we have instantiated the object. Now we can insert the job. Insert the jobs into the run queue or priority queue. Basically, going to insert it with the PQ object into the run queue that we have defined. So it's going to be PQ object dot insert job, and that takes three parameters: name, priority, and ID. So we can pass anything as you see here. So we can start with something like ID 44, Acrobat, and 11. Name is Acrobat. ID is 44 and priority is 11. We are inserting it first. However, it takes a different position depending upon the new job that's coming in. Based on the priority, we will insert them accordingly. So the next job that we are going to insert will be different. So I'm just going to take this. We can insert Chrome and that's going to hold priority 0 ID 11. We can insert Vim 14 and 36. Next will be edge priority 21 and ID 21. And finally, we will have Skype inserted with priority 1 and ID 2. So when we are inserting this, we have first Acrobat inserted, and then Chrome, Vim, Edge, and Skype. However, based on the priorities, we will have Chrome, Skype, Acrobat, Vim, and Edge in the run queue lined up for scheduling. We can verify that with the dumping of the run queue. We can do that right away. But for now, we will see the insertion function is implemented like this. We can now implement dumping of the queue. PQ object dot list run queue, and list run queue need to be implemented here. So we'll implement that. Dump the current state of the run queue. So whenever we call this list run queue function, it dumps the current state. So if we are going to call it here after insertion of all the 5 jobs, it's going to show the current state. Function list run queue takes no parameter, and we have this interface, this star priority queue. Okay, I'm going to have a variable current that's going to be used as a walker, and I'm going to point that head initially. Next, walk over the run queue and dump the values. So for cur not equal to nil, cur equal to cur dot next, and before we move into cur dot next, we will dump it. Dump the current node. Printf job ID equal to percentage d, an integer value. Job priority equal to, that is also percentage d, an integer value. I'll keep slash in here, and I'll have job name showing up first. That's going to be a string. So we leave little space and declare those variables. That's going to be current dot name, current dot id, and current dot prior. That's it. Okay. We can save this and verify the function of inserting these 5 jobs into the run queue, and then also reporting them with list run queue. Just going to open up the terminal here. walk into the corresponding folder. Okay. The file name is scheduler priority. Okay. We can run it right away. I want to run the scheduler now, and we are going to see the job lined up as you see here. Chrome to begin with, Skype, Acrobat, Vim, and Edge. The order in which we have inserted this job is different to the order in which they are lined up for scheduling. That's because of the priority. Perfect. We see Chrome with priority 0 lined up first and Edge with priority value 21 lined up last. So based on the priority values, the jobs are lined up. So the earliest task for scheduling is Chrome and the last task for scheduling is Edge. The priority is 0 here for Chrome and priority is 21 for Edge. And it's an increasing order of priority starting all the way through Chrome through Edge. We can swap the order in which we are invoking list run queue. So I just trim this and insert it here immediately after insertion of this free job and comment it up. Now we see Acrobat inserted first, followed by Chrome, and then finally Vim. I'll flare up the screen here, save it, and run it again. So now again we should be able to see Chrome, Acrobat, and finally Vim showing up in the run queue based on the prior Chrome, Acrobat, and Vim. That's perfect. Now if we add Edge as well, I save it. We'll run it once again. So we have Edge showing up in the last because it has priority value that's very larger than rest of the jobs in the queue. So it shows up in the end. That's it. So we have seen the working behavior of insertion of the job into the run queue and their positions in the run queue with list run queue function. Our final task will be now to implement the scheduling task. Let's do that right away. Going to insert the last job also, Skype, and then keep it as is. Okay, now we are good to implement scheduler. So I'm going to minimize the screen and start implementing scheduler. In part, implementing the DQ operation. Basically, we are going to pull the task from the head of the run queue. For sake of simplicity, here scheduling is going to be just dumping the values of the given job. Normally, scheduling of a job is as good as deployment, but we are not going to perform any deployment, but just dump the values here. I'll perform the same task here. Function this star priority queue schedule takes no parameter. The schedule the given task at head of the run queue. So if run queue is empty, we simply return. So if this dot head equal to nil, return. I'll comment it here. If run queue is empty, no job to schedule. Otherwise, we schedule the first job, the head of the run queue. So here it's as good as dequeuing the job equal to this dot head. I'm just extracting the first job from the head of the run queue, and we could print the credentials of this job here for sake of debug. I'm just going to say this as a debug message. It's going to be job.name, job.id, and job.priority. So this indicates that on invocation of schedule in the main driver, we'll have the task sitting at front of the run queue or head of the run queue implemented or executed. I changed the head pointer now, so this dot head is now going to be the next node in the run queue. This dot head dot. In addition to printing here, we could also return job. So to return job, I need to have a return variable that's going to be of type job. This is return nil. Okay. We can invoke schedule here after listing the jobs that has been pushed into the run queue. So we have pushed 5 jobs into the run queue and we have successfully listed them as well. So we know at top of the run queue or in the front of the run queue is Chrome. And when we invoke schedule, we are going to have Chrome ready for schedule. So I'm going to say PQ object dot schedule. This is going to schedule the first job in the front of the run queue. Scheduling job 1. Now if we again talk, we are just going to have all the jobs except Chrome in the run queue. So we should have 2 printf statements followed by list run queue here. Or maybe I can comment it out. Yeah. So we're going to have 2 printf statements. One is the job that is getting scheduled. So it's going to be Chrome. And if we are going to have the our job in run queue, that's going to be everything except Chrome. We're going to save this now. We can run it. Yes, so Chrome is the one that is getting scheduled, and these are the jobs that are in the run queue after scheduling. Perfect. It's as expected. We can call schedule few more times. So this time we have three jobs scheduled. So it's going to be Chrome, Skype, and Acrobat scheduled, and the leftover jobs in the run queue will be on will maintain. We can verify that. Let me save it once again and run it. Perfect. As expected, we have Chrome, Skype, and Acrobat scheduled, and the leftover jobs are Webmet, which let's clear it again and have all the jobs scheduled from the run queue at one shot. So I'm going to modify this a little bit. Schedule all the jobs from the run queue. Let me clean up this. So I'm going to find job to head pqobj dot head. So job not equal to nil, job equal to pqobj dot schedule. This is going to schedule all the jobs one by one until the run queue is empty. So we'll save this and then rerun it. So this is going to show the debug statements here in the schedule function for all the jobs in the run queue based on the priority. We're going to have Chrome first and all the way through until Edge. Perfect. If run queue is one thing that is worth observing is that list run queue dumps nothing here in the result because there is no job left in the run queue if all the jobs are scheduled. So what I'm going to do is I'm going to move this list run queue to be dumping the current state of the run queue after every execution of schedule. So first time when schedule is called, we are going to have everything except Chrome. The next time we are going to have everything except Chrome and Skype. And the third time we're going to have everything except Chrome, Skype, and Acrobat. And then everything except all of this holding only Edge. So it keeps dequeuing the element or node at the front of the queue, and we see that gradually getting scheduled. So let us do that now. Okay, I'm going to save this here and we'll see the transformation of the run queue as the jobs are getting scheduled. So we have debug statement from here and all the four tasks dumped by plus queue. Perfect. Now we have debug Skype and only three tasks left over in the run queue. We have now Acrobat scheduled, only two tasks left over in the run queue. Vim scheduled, and there is only one task left over in the run queue. And then finally we have Edge scheduled and no task left over in the run queue. Perfect. I'll clear it once more. Now we know that if there are no jobs in the run queue, then the schedule function would simply return nil. So we can verify that here. make an attempt to schedule a job when run queue is empty. When we are done with scheduling all the jobs in the run queue is obviously empty. So now if we make an attempt to schedule, that is job equal to pqobj dot schedule, we should get nil. If job equal to nil, then we say no job to schedule. So this is the expected result. Otherwise, fmt dot println, we should say scheduler is not working as expected. We don't need a new line separator here because we are already using println. Okay, so we should get no job to schedule. Scheduler is not working as expected, should not be printed. Let's save this and run it now. After all the jobs are scheduled, we have no job schedule. So scheduler is working perfectly as expected. There's one more thing to be observed. We are initially setting job to point to the head of the run queue. And if run queue was empty, it would never enter into this queue. So all working perfectly. We are done with implementing job scheduler based on priority of the job. We wind up on this problem. I just want to make a tiny optimization to the scheduler over here, particularly with respect to error handling. So I'm just going to add error here. So we return both job details and error if job is nil. So if run queue is empty, we return nil and we say no jobs for scheduling. Okay. And here the error becomes nil if DQ operation is successful. Basically, if there are jobs that have been scheduled. Further, we need to make changes to the scheduling section in the driver as well. Let's do it. I'm going to clean up all of this and introduce the scheduling section separately to handle the error content also. I'm just going to delete this. Let me uncomment this and then now schedule all the jobs from the run queue. This time with a different style. So go to initialize job and pqobj dot schedule and list the job until error equal to nil. update the job with again scheduling function. Now dump the list. So I'm going to call this once again. That's it. Let me save it. Maximize this section. Let me clear the screen. So we'll quickly check if everything is okay. This seems to be an error. We'll fix this. And here I see it need to be error that will be returned. Okay. I'm going to pull up the job details from here and dump. Let me comment this so that we don't get confused with what is being printed during the schedule and listing it over here. So we will dump the job that is getting scheduled and then the list after the job is scheduled. So that will be the leftover list that will be reported here. This will list the leftover part of the run queue. Okay, so we are good to run this. All the jobs will be scheduled, and after each job, we're going to see the leftover run queue. This is coming from insert jobs. All of this is coming from this portion in the main driver. So first we are having Chrome that is scheduled and the leftover run queue is like this. Next we have Skype. The leftover run queue will have 3 jobs. Then we have Acrobat. Leftover run queue will have 2 jobs. Then we have Vim. We have only Edge leftover. Finally, we scheduled Edge and there is nothing left over in the run queue. So we are done with the implementation, both the regular way and the optimized way.